Okay, in this video we're going to go over your dilutions, and we're also going to go over parts per million, because I apologize I didn't put it on the other uh, concentration part. So that's another type of concentration we'll go over just a sec. But for dilutions, this is when you're diluting, you are essentially adding solvent, right? So the mass is, or the mass of the solute or the moles of the solute is going to be the same. So let's think about this. We know that molarity is moles over liters. So if we rearrange the variables, we get molarity times liters equals the moles. But in dilutions, the mass or moles of solute stays the same. Moles. So the moles before and the moles after is the same, right? So inserting, instead of saying moles, we'll do molarity times liters, right? So the molarity times liters before is the molarity times the liters after. So another way to say liters is just to write volume, right? So that's where we get this equation, and I ran out of time. M1 V1 equals M2 V2. That's your dilution formula. Now this formula is only used for dilutions. It cannot be used for stoichiometry because stoichiometry, the moles is changing, right? But here for dilutions, it works. So this is a real convenient thing to use and real simple to use. And dilution questions rarely stand alone by themselves like they do in these examples. They're normally wrapped into some other type of question. So watch out for those. You need to be responsible and be able to do these. So if 50 milliliters of a 18 molar solution of H2SO4 is diluted to a total volume of 2.5 liters, what is the new solution? So I'm going to make sure I have my units matching. I have milliliters and liters here. So that must mean that my initial molarity, my M1, was 18 molar. My initial volume was, I'm going to go ahead and convert that, 0.05 liters. And then my second volume, molarity is what I'm looking for. And then my volume is 2.5 liters. So simply it's 18 times 0.05 and then times x by 2.5. So very simple. And so 0.36 molar. Okay. And does that make sense? Well, it was really concentrated, but we only used a little bit. And then if we added lots and lots of water, like way more than, like a lot more, then the concentration went down a lot. So you have the same number of sulfuric acid atoms as before, sulfuric acid molecules, but you have more volume. So now the volume of 6 molar HCl needed to make 6 molar HCl needed to make 150 milliliters of a 0.2 molar solution. So again, this term and this term are married together, right? So you can make this your M1, or actually your M2, sorry. The volume, that's what I want to know. This is my M1. This is my V2. This is my M2. So 6 times X, 150, 0.2. I switched those around, but that's okay. I'm multiplying. That's going to be 5. 5 milliliters. Okay, keep the same units. All right, the units, it doesn't have to be in liters. The volume does not have to be in liters, but the volumes just need to match on either side. Okay, it doesn't necessarily have to be in liters, it can be in milliliters. All right, so let's take a look at parts per million. Now, this is something that's pretty new, and it's something that's on the test, and a lot of students trip up on it because you have to think about the mass of the component divided by the total mass of solution. So that is the mass of the solute plus the mass of the solvent. Okay? That top part is the mass of the solute. So, and then you'll multiply by 1,000,000. Okay? So 1 milligram of solute is in 1 liter is going to be 1 part per million. So if we have 17 grams of sucrose in 183 grams of water, the concentration in ppm is going to be 17 grams, and then we'll do 17 grams plus 183 grams times 1,000,000, 10 to the 6th. And so that's going to be 85,000 parts per million. If you're going to find parts per billion, ppb, then that's going to be 10. You're going to multiply by 10 to the minus 9. I mean 10 to the 9, because that's another 3 zeros. Now, a certain pesticide has a toxic solubility of 5 grams per kilogram of body weight. That's sometimes called the LD50, the lethal dose of 50% of the population. That's what that's called. Of 5 grams per kilogram of body weight, what is the solubility in ppm? So 5 grams per kilogram of body weight, so we're going to do 5 grams, and then we're going to do 5 grams plus 1,000 grams times 10 to the 6th. So that's going to be 4,975 parts per million.